These batteries are available today. Not just available for OEMs to look at in the lab, and not just available to prototype with, but available for real production.
The automotive world is no stranger to miracle breakthroughs that promise to change everything only to vanish into the footnotes of history. But even by the standards of high-tech hype, Donut Lab has managed to do something extraordinary. Within the span of a few weeks, this small startup has claimed to achieve what giants like Toyota, Samsung, and Tesla have failed to do after decades of research and billions in investment: the mass production of an all-solid-state battery. On paper, the specs are nothing short of divine. Imagine an electric vehicle battery with 400 Wh per kilogram energy density, a full charge time of just 5 minutes, and a lifespan of 100 years. Oh, and one more thing. It supposedly contains zero lithium. It sounds like the holy grail that would end range anxiety and fossil fuel dependence forever. However, as the dust settles from their flashy CES 2026 presentation, the donut is starting to look more like a hollow ring than a solid revolution. From empty battery casings on the display floor to a total lack of independent verification, and a CEO with a history of making super claims that never materialize, the red flags are mounting. The industry's biggest players are now calling foul, and the scientific community is demanding proof that simply doesn't exist. Today, we are pulling back the curtain on the technical impossibilities, the corporate mysteries, and the cold, hard physics that explain why Donut Lab couldn't and likely hasn't mass-produced an all-solid-state battery. You know, in the battery world, energy density is the ultimate truth teller. It represents the amount of energy stored in a given mass. And for decades, the industry has fought for every single W-hour. When Donut Lab announced a baseline of 400 W-hours per kilogram, they weren't just proposing an improvement. They were claiming to have double the performance of the most advanced batteries currently on the road. Okay, to put this in perspective, let's look at the current leaders. Tesla 4680 sells approximately 244 to 272 W-hours per kilogram. High-end NCM cells peak around 250 W-hours per kilogram, and 70% of the world's batteries are LFP batteries, which have an energy density of only about 165 W-hours per kilogram. For a startup to leapfrog the theoretical limits of liquid electrolyte batteries, while simultaneously claiming zero use of lithium, is scientifically speaking a staggering claim. In the world of electrochemistry, lithium is chosen precisely because it is the lightest metal with the highest electrochemical potential. If you remove lithium from the equation, you are typically left with heavier alternatives like sodium or zinc, which struggle to even hit 200 W-hours per kilogram. And we all know if you want high energy density, you usually sacrifice cycle life because the materials expand and contract violently during use. If you want ultra-fast charging, you risk generating massive heat and creating dendrites, microscopic spikes that pierce the battery and cause fires. Donut Lab claims to have solved all of this. 400 W-hours per kilogram, 5-minute charging, and a 100,000 cycle lifespan. It's like claiming you built a car that goes 500 miles per hour, gets 1,000 M per gallon, and lasts for 1,000,000 years without an oil change, says an industry analyst. Any one of those claims is a Nobel Prize. All three together, that's a red flag. The most damning evidence against Donut Lab isn't just the math. It's the reaction from those who actually build the world's batteries. Rico Ulisse, a senior executive at CATL, the world's largest battery manufacturer, didn't mince words. He publicly labeled Donut Lab's claims as clearly false. Coming from CATL, this is an unprecedented move. Major corporations usually ignore small startups to avoid giving them free publicity. However, the claims made by Donut Lab were so contradictory to the fundamental data CATL has gathered from spending billions on R&D that they felt a public correction was necessary. If a material existed that could deliver these specs without lithium, Cattle with its thousands of scientists would either be using it or trying to buy the company. Instead, they are warning the market to stay away. Yeah, the final blow to the 400 W-hours per kilogram narrative came at CES 2026. While the marketing video showed sleek animations of clay-like materials and battery printing, the physical booth told a different story. Instead of a working prototype or a live test of a cell powering a motor, Donut Lab displayed empty battery casings and 3D printed models. But, the skepticism surrounding Donut Lab doesn't just stem from the impossible physics of their claims. It is deeply rooted in the structural reality of the company itself. In the hyperco-competitive world of energy storage, achieving even a 5% incremental gain in energy density requires a literal army of experts. Global titans like Panasonic LG Energy Solution and Samsung SDI employ thousands of electrochemists and material scientists who spend decades in multi-billion-dollar laboratories. In stark contrast, Donut Lab is an anomaly that defies industry logic. Public records from late 2025 indicated that the company operated with a skeleton crew of approximately 9 employees. Even more staggering is the fact that among this handful of staff, only one person possessed a technical background directly related to battery engineering. The rest of the team consisted of experts in branding, digital marketing, and project management. This raises a fundamental question that the industry cannot ignore. How could a team smaller than a local football club outperform the collective brilliance of the world's largest R&D departments to solve the most difficult puzzle in modern science? The spotlight naturally falls on Marco Limiaki, the CEO of Donut Lab, whose career trajectory is as colorful as it is disconnected from the world of electrochemistry.